Once you got a general sense of weather data of your interest, now you can use Climate Consultant software, which will take the same weather data that you previously used and start showing the possibility of a more specified design direction. I find this software much more helpful only if you have certain amount of understanding of the weather data prior to use this and knowing what to expect. Open the software and click through first few pages. And you can click on start a new project. And you can click appropriate building type and the unit system that you'd like to use. And you can click open existing APW weather file. And you can navigate to the folder that you downloaded. In this case, I'll use the Phoenix data. And the next page automatically shows the average summary of the weather data that you just brought in. Just quickly check if this seems to be correct and click next. And this software also takes some guidelines to produce some of the useful suggestion at the end. For most projects, we use ASHRAE standard 55 because it's mostly widely used guideline. On the next page, it gives you opportunity to take some design assumptions. If you know that your building will be allowed to have more moderate closing factors than usual buildings, you can tweak it here. Also give you some mechanical assumption change if you know it will be different. And it also give you to tweak some of the information related to your building's materiality as well. But for most of the cases, it's okay to leave this as a default. And click next. You can immediately see the temperature graph. The format is quite easy to understand. It gives you mean and average by different color, and also give you recorded high data points. And next page is very useful information for designing your building because it gives you a combination of graph between the solar radiation and the diurnal pattern of the temperature. Here, in this case, in Phoenix, we see a great amount of solar radiation, and we see greater amount of time that is already above the comfort zone. So therefore, by looking at this graph, I would want to block as much as solar radiation for this period of time. And I will try to utilize some of the solar intake to bring some of these data points up to the solar radiation. So your building geometry can be immediately informed by looking at this graph. I also noticed that the wet bulb mean temperature and dry bulb mean temperature is quite further apart because of the dry temperature. And I see great potential for evaporative cooling if you have a chance to apply that. It gives you a series of useful data with based on widely used graphic language, just in case solar light, illumination range, and sky cover range. This one, I see average data points to be between 30 and 50% of sky cover, but I see it's pretty unpredictable for this climate because this data point cloud is pretty wide. Wind velocity range, it has average very low wind velocity, but I see some extreme cases of wind happening. This is ground temperature. By looking at this, you can see the potential for geothermal possibly. It shows the temperature fluctuation based on the elevation from the surface ground elevation. You can see 4 meters below the ground surface, you see less variation of the temperatures throughout the year. And you see here you see dry bulb and relative humidity comparison for January to December. You can see obviously the inverse relationship between the temperature and humidity. Here you can find the sun shading chart. It shows temperature range that is based on 2 portions of the year. You see later portion of the year and earlier portion of the year. And here you can apply display shading calculator, and you can schematically determine what your shading angle has to be. In this case, in order to block most of the uncomfort temperature, your horizontal shading has to be quite tilted for the earlier part of the year, but for the later the later part of the year. For the earlier part of the year, you are if with using that angle, you're already blocking out some of the useful solar radiation to heat up these data points. So you can start to see interesting geometry can come up to mitigate between the two periods of the year.